Thank you all for joining the second session of the event Decoding AI. And I welcome you all. So I will not waste more time waiting for others to join. So let's start with the recap of what we did in the last class. And as you know, today's session is Python for data analysis. So we will be doing programming. And you can follow with me. I will share the necessary files with you on chat box, and you can download those files from there, and then you can work with me. So let's start with Python for data analysis. So is there anyone who is familiar with Python? Okay, so I'm assuming it will be a fun ride for you all. So let's start with presentation and then we'll start with programming. So let me share my screen with you. Okay. So today's topic, as you can see, it's Python for data analysis. And we have discussed some basics about the data in the last class. And I introduced what is data to you, what are the different types of data. So we'll just do a quick recap for those who have just joined today. So before we start with the actual concepts, let's discuss the session layout. So I will be discussing data basics as well as there is a new concept which is called open data. I will be discussing and mentioning you. I'll take you, walk you through the open data portals, and then what exactly is open data, how you can download the data from those open data publicly available data sets. Then we'll learn how to download it and then clean it. So these are basically the data analysis steps. First, we'll do some theory. Let's get the basics of it. And then we will do actual programming. So these are the next two topics: download, clean, explore, analyze, and visualize the data sets. They will be covered with programming as well as with some theory behind those actions. And then it will be followed by a brief or short presentation by a high school student where you can see how data analysis is used to get some very interesting insights from the COVID data sets. So let's start. So this is something from what we have already done in the last class, and I won't spend too much time on this. So Python is one of the most popular languages these days, and especially for data analysis. And these are some of the reasons why it is very popular. First is open source. Open source means it's freely available. Anybody can just go and download from python.org. You can do it, and it has been bundled with several platforms. So that is why since it's free, it's called open source. And the next is it's very easy to use and simple to understand. Most of the words, programming words, which you will see which are being used in this programming with Python, they have borrowed it from English. So it's very easy to understand just by taking a look at the name of the function. You will understand that, okay, why we are using this and how it will be used. And the next thing is it has huge library of functions which are already built in the packages. So the library, we discussed about different libraries, and libraries are basically the collection of functions, and those functions can handle different kind of jobs. So now you don't have to write a long list of code, a long line of codes, or a long block of codes just for doing a simple work. Instead, you can just call a Python function and get the work done. So instead of writing 4 or 5 lines, getting the work done, now you can just write 1 line of code and you'll see very complex tasks can be accomplished just by using those functions. Okay, so that is why it's very easy, convenient to use. So because of this, because of many packages, it's very easy to use. So that is why the less line of codes are required. So your work is reduced a lot. So again, let's discuss what exactly is data. Data is a set of observations. And observations are, in other words, you can say that it's a facts collected for analysis. Now, data, there is no hard and fast rule that, okay, that is how you have to collect data. Because data, it totally depends on what kind of problem or what kind of uh, observations you want to record. Okay, so it totally depends on what kind of problem you are trying to solve, and the data that will be collected, it will be centered around the problem. So not for every problem, we don't collect the same kind of data. So the data collection totally depends on the kind of problem we are solving. And this is a sample data. It's a data of a class where we want to know the average age or average weight of students in the class. And then that is why we recorded the date, weight, and height of students, because we just want to know the average. We are not bothered about what is their marks or something, because we just want to know what is the age and weight. So that is why we don't collect anything that is not necessary. Types of data. So this is your data, and there are two main types of data you can call. So one is qualitative or categorical, and the other is quantitative or numerical. So as you can see that quantitative data is easy to understand because it has to do something with numbers. So quantitative data is the data which is either in whole numbers or it is in uh, floating point numbers or decimal numbers. Whereas in qualitative data, now, if I want to define the quality of a data, as if whether it's a yes, no answer, or whether it's when we talk about temperatures, last time I mentioned that it's whether it's sunny or it's uh, rainy or it's warm weather or it's a cold weather. So these are basically you are defining the quality of that particular data point. So when you do such kind of things, then it becomes a qualitative data sets. It's sometimes called categorical because if suppose we are talking about the different continents in the world, and if we want to define that, okay, what kind of continent this particular country or particular statistics is from, then we write the name of the continents like Europe, Asia. So then it again, we are defining the categories. So that's why it's also called categorical data. And then it is a quantitative data set. So it is of two types. One is discrete and one is continuous. So discrete is basically when we talk about whole numbers, 1, 2, 3, 4, any number which cannot be further divided, that is called discrete. That means whole numbers. And continuous data sets are those data sets where you have uh, a decimal point. So if you are talking about floating point numbers or decimal numbers, then we talk about continuous data. So this brings to the main topic of today, and that is what is data analysis. So basically, interpretation of data to provide useful insights. So that is how we define data analysis. So acquiring acquiring data from primary or secondary data sources, and then maintaining databases. This is also the job of data analysis. So in nutshell, you can say that data analysis is identify, analyze, or interpret trends to get useful insights from the data. And that is called your data analysis. So main job is to find the trends, or if your data, because when you have numbers in front of you, you cannot say anything about those numbers or what the numbers are trying to display or portray. So when you start digging more into your data sets, then you start getting some patterns or trends. And that basically defines the characteristics of your data set, and you can get some very useful information from that data set. So we will make the journey from having just raw numbers to a place where we can say, okay, my numbers are saying this, my numbers are saying that. So that is journey is basically your data analysis. Next is, what is open data? Open data is sometimes called public data. Okay, so what exactly is this? So open data is a data which is available for public free. Anybody can use it. There are no strings attached to it, especially licensing or copyrights. It's free for anybody to use it, and they can use it for commercial use or any for their personal use. It totally depends on the individual how they want to use it. So there are no restrictions on using that kind of data. And I will with you I will explore some sites where you can get public data. So generally it's open data is an initiative which is being adopted by different government agencies because they want to be transparent. Also, governments want more and more people to use that data so that they come up with useful insights, and they can suggest some things to the government, and the policies can be made by from the insights of those data sets. So if you wherever you are, if you try to find your government agencies data, you will see that many of the countries have their data sets, so from the different departments. So I have taken some examples from city data sets. So like in New York City, there is a data initiative, and which is called NYC Open Data. I'll take you to that website because today's data analysis, we'll download data from there, and then we'll analyze one of the data sets from NYC. Then data.gov is an initiative. And then if you go to any city, you will see they have their own open data sites. And you will find all kinds of data sets in these particular sites. Their traffic data, finance data, schooling data, school districts. So you will be overwhelmed by the type of data sets that are available now, free of cost, and you can use it. Financial data, some of the examples are World Bank, IMF, International Monetary Fund. New York Stock Exchange has a lot of historical data. NASDAQ has data sets. The World Federation of Exchanges, where you can get data sets about different stock exchanges. Health data can be, now every city, many big cities have their own health departments. You can get their data sets. Even the state governments have their Department of Health, where you can get all kind of data sets. And one of the most popular data sets, health data, can be found from World Health Organization, CDC, Johns Hopkins University, and so on. Now, there are some individuals and organizations who submit data sets to these two. One, they are very popular. One is Kaggle, and then another is data.world. And Kaggle actually is a very huge site where you can get a lot of data sets, and they have so many competitions about in data analysis and machine learning. So it's a complete package where you can learn, because there are so many people who have solved put their data projects on that particular site. There are so many competitions that are available there. So if you are really interested, you can feel free to explore these sites. And then there are some other kinds of data sets. For example, entertainment, transport, crime, you can get it from um, frauds, even banks, you can, all kind of data sets are available. So let me quickly take you to this OpenSeta, different sites which I have mentioned. Let me take you to those sites, and I'll show you how we can download from there, and what basically how these data sets look like. So let me do, I'll share my screen with you. Okay, so this is one of the site which I mentioned. It's called data.world. You have to make a login. You have to create an account. And as you can see, there are so many data sets available. So visualizing conflict, and this is data.world is mostly data set, has mostly data sets from individuals or companies who have submitted their data sets for public use. So you will see a lot of people have already worked on those data sets, and you can see. So this is visualizing conflict, and as you can see, the visualization is there. So this is the last part of your data analysis. So as you can see, so if you want to work on these data sets, you can follow people, how they have solved this problem. So just go through all these, whatever interests you, because they have data on different uh, fields. So you can search for financial data set, and you will get a lot of. So as you can see, these are the financial data sets. So this is data.world. And then let me take you to Kaggle data sets. So you can create your public data set also. And as UK, because of the COVID times, you can see there are a lot of data sets submitted by different organization, as well as submitted by different individuals. And there is a challenge also. So if you take a look at the left-hand side of this web page, you will see there is something called data. And you can search for data sets also, just like data.word. As you can see, financial data sets are there. So in different data sets, you will be able to see. Let's see the groceries data set. And there is a description of the data and size of the data. And this is the data, actual data set, which you can download. And these are the visualization. The person who has analyzed it, they have given you some results also. You can see uh, the analysis part also. They have given you the programming notebooks also. So you can just, if you want, you can just copy from there. So it's a very interesting, these are very interesting places where you can just go if you are interested in doing data analysis. You can just go and play around with these files and make your changes and see how people have done it. Because these are the best places to learn uh, about data analysis, because they give you a different problems, because for to handle different problems, there are different ways. So if you want to learn more and more, it's the first step is to follow what the other people have done, and then you can make changes in those, just play around with those files. So this is Kaggle. And then this is International Monetary Fund, IMF. You can get different demographics, a lot of data sets about different countries. So you can see popular data sets, balance of payments, financial development, global statistics you can find about different countries. So these are very huge uh, resource. They are very big resources for different kind of economic if you want to do analyze economy, or if you want to do some health status of throughout the world. There are so many data sets you can just explore. So this is IMF, and we have, this is New York Stock Exchange. So this is market data, and you can go to historical. So if you want to know the stock prices for the last 10 years, you can do it. I generally prefer Yahoo.Finance, Yahoo Finance. If you want to know the historical prices of different stocks, they have a very easy interface to download. You can download it as far in the past as you want to. And they are very good for analyzing financial data. So this is New York Stock Exchange. Then we have CDC website. You can get a lot of, if you want to analyze anything that has to do with health statistics, this is a good website. So most of the data sets follow the similar kind of way to download data, or how the data description is given. So it's not very complicated to go through these websites and figure out that how will I be downloading these data sets. So this is CDC, and I will take you to New York City Open Data. If you search NYC Open Data, the first link which you get is NYC Open Data. Okay. Now they have different, I have been part of New York City Open Data Initiative. So they are a very good resource for not only for data sets. They organize a lot of events for people who are in the field of data analysis or data scientists, and they have very nice events. They celebrate 1 week in March where they conduct Open Data Week, and they have so many events. So you can explore this website. They have very simple and very interesting data sets. So let's go to now discover New York City data sets by category. So I'm going to click this. And as you can see, data sets by category. And I will be using one of their data sets, and that is in health. And this is the first data set which they had, is New York City leading causes of deaths. Now, we will be doing analysis of this data set. Now, if you take a look at this data portal, New York City Open Data, and you look at the CDC website, you will find similarities in both the sites. Okay, and so they have a similar way of downloading. So let me click to this. I'll click this link, and I'll explain it to you, the whole interface or the web page. So this is a page which gives the metadata. Now, what is a metadata? Metadata is basically the data about data. So the data, you have seen, this is your data set, where there are some columns and there are some rows. Now, the information about this data is called metadata. So as you can see about this data set, it's last updated February 7. Now views 173,000, 39,000 times it has been downloaded. And this is something important. Let me make this a big page. As you can see on the left-hand side, Department of Health and Mental Hygiene. So this is the source of data. They have provided this data sets on Open Data Portal. And this is the actual file on the right hand side. This XLSX is the actual file. And then we have some other information about this data sets. One of the most important is it has 1094 rows and 7 columns. And each row is a cause of death. Okay. And then we have 7 columns, the name of the columns and what exactly it portrays, it represents. So as you can see, there is a description given. Okay. So this is basically your metadata. And then you can view data. Okay. Now, when we come to this part, you can see there is a data given. So suppose you are using this CDC, this NYC Open Data and you want to download this data file. So the best way is to click export. And on the right hand side, there are some options given: more views, filter, visualize, export. And if you want to download this data, do export download. And then you have to click this, and the best thing to download, the best way to download it is to download as CSV. So I'm going to click this. You don't have to do it because I already have this file. So I will paste this file on the chat box so that you all can download it from there. And then you can save wherever you want to save. Okay. So this is how you download the data, and you can start working on from any of these sites. You are free to download the data. So what IDE we will be using? We will be working on Jupyter Notebook. So we will be working on Jupyter Notebook, and okay. So what you can do, I'll take you, there are different ways of doing it. So when we'll do programming, I'll walk you through every step. So this, I hope you all have understood that how exactly you can use open data, what kind of data portals are there, and how you can step by step, how you can download it. Okay, so every of these open data sites have mechanisms for downloading the data set. So feel free, because they are open data. So you don't have to tell anyone, you don't have to take permission from anyone. Just visit their site, and whichever data set you like, you can just download that data set. I would suggest that not only you download the data set, you should also download the metadata. Because if you are presenting, if you are doing a project and you want to present it to someone, you should be explaining where you got this data set from, because that tells you how authentic is your data set. Because generally government agencies have authentic data sets, as well as New York Stock Exchange and NASDAQ and WHO, because these are all very established agencies, and they have ample of data sets. So I would suggest that you should be, before you download it, you should have also metadata. You will be able, because you can always refer back to your metadata to see what exactly the column names or what exactly each row is representing. Because if you don't know that, then you will not be able to formulate questions or hypotheses on your data sets. Okay, so these are some things which you should be remembering. So let's go back to our presentation and learn the different steps of data analysis. So we have seen what is open data. So let's go back to. So there are two very important things or concepts which you will be using. One is the data frame. I will be using this word a lot because I explained the data in the last class that, okay, you can write your data set in a tabular form, which has some rows and some columns. So what are rows and what are columns? So I'm just repeating it, but now instead of saying a table, when we use a programming, we always call them a data frame. And this is a Python language. So what exactly is a data frame? Data frame is basically a table. It's a rectangular layout of your data, but it's called data frame. So it's a two-dimensional data structure. What is a data structure? Data structure is basically the way you save your data. So you hold your data is called data structure. So last time we talked about variable. Now variables can hold only one value. If you want to store a group of values or a set of values, then we use data structures. Okay. So it's basically a two-dimensional data structure, and where the data is organized in the form of rows and columns. So you can see this picture. It's a sample data frame. Okay, and the next thing which we will talk about is pandas. So the different libraries which we talk about in Python for data analysis, we used pandas library, and this is rich with different kind of functions which we will be using for doing our data analysis. So it's basically a software library. So I will tell you when we start programming, I'll tell you how different components are called in a program. So I'll explain it to you how basically when you do programming, how things take place. Now, Jupyter Notebook, as someone asked me which ID we will be using, so we'll work on Jupyter Notebook. It's an open source web application. So the best part is it's a complete environment in which if you write Python code and you run it, so it is environment where your Python compiler is already there. It's basically a whole environment where you can write your program. So it's editor also. And then when you run it, it processes your program, it compiles your program, and then it gives the output. And it's a very simple, its layout is very simple. It's very simple to use. It's very simple to debug, because if you write your code, if you are trying to do one task and you write that task in just one single line, then it's always easier. You can always come back to that particular cell. I'll explain when I'll start with Jupyter Notebook, I'll explain each component of Jupyter Notebook so that you know what which term stands for what. So there are so many uses of Jupyter Notebook. You can do any kind of programming here, and mainly it's used for doing Python programming. It's also used for doing R programming. And when you can always, there are two ways of using it. I'll mention in the later slides. So instead of me telling you that it's very simple to use, I'm pretty sure when you use it, you yourself will say that it's really easy to use, neat, and you can always share these codes. You can save them, and Jupyter Notebook, you can open it wherever there is a Python editor. Now let's come to data analysis. So data analysis has several steps, and first of them is data collection or downloading data. So nowadays, generally, data collection part, you don't have to collect data unless and until you are doing some project which you have created a project, so you may want to collect data. Otherwise, generally, people work on data sets which are already available. So it's the first step of doing data analysis. Then we explore our data set. Exploration means basically you want to feel your data sets. You want to know what are the different, how many rows are there, how many columns are there, what are the names of the columns, how you can access a particular value in the in your data set. And these are some of things because you may want to feel your data is my so during the exploration, one of the main things is if you have data set has missing data, because missing data is a very big problem and very big challenge while you're doing data analysis. So exploration gives you feel of your data set. Then if you have, when you explored your data sets, you will find some challenges or some shortcomings in your data set. So you may want to clean your data sets. So basically, these are the steps where we are preparing our data for analyzing. So after you have explored your data sets and you know what are the different things in my data sets, you may find some problems. So you may want to clean your data sets. Now, what kind of problems can be there? I will, for example, I'll mention some of the problems, and one of them is handling missing data. So you may want to get rid of all the problems so that you, whatever uh, objective you have created for data analysis, it caters to that. So this is another big challenge. Then comes the analyzing part. So although the topic is data analysis, then analyzing part is not very complicated, I would say, because exploration is easy, cleaning data and preparing your data is a very big challenge. Okay, so analyzing data is analyzing data analysis will use some functions, and those functions totally depends on what kind of analysis we want to do or what kind of questions we want to answer. And then this is the last part of your analysis, and that is doing visualization. Now you may do data analysis for 2 or 3 reasons. You may want to present it to your class, or you may want to present it to your peers, you may want to present it to your superiors. So it's a challenge that because you, whatever patterns or trends you have found in your data set, you will not, it's not a good practice to give your data as it is, the results in a tabular form, because visualization pictures always create more effect to human mind rather than just numbers or text. So that is why data visualization is a very, very big branch of data analysis. And it's a complete course in itself. So there are so many techniques, but we will be, since it's a part of our analysis, so we will be making some charts and graphs, and we will be presenting whatever results we got, we will present it in a form of a graph so that it's easily understandable by the people who are my audience. Okay, so who are for whom I have prepared my, I've done my analysis. Or even if you want to use it for yourself, it's always a good practice. Now, interpretation, this is the final step. And this preparing report completes your data analysis process because it summarizes the findings, and it's for the benefit of presentation that, okay, you have all the results summarized at one place. So if we have time, I'll show you a sample report and how we will, whatever report or whatever analysis we have done, we'll just try to give some interpretation or summarize those results in the form of a report. So step 1, data collection, download. We can download from a site. Now, CSV file, I have shown you how you can download from a CSV file. It's a very popular way of storing data. So we will be using a CSV file for New York City leading causes of deaths. It's a most popular way of storing data. It's a comma separated values. There are several other forms of data, and it can be a text, PDF, JSON, XML. These are the different formats for storing data, but they are complicated, higher level, advanced concepts. So we will be using a very easy way, which very popular, very used, very well used, which is CSV files. So the first thing is you downloaded it and now you want to read data in program. So we will be using that. Step 2 and 3, data exploration and cleaning. So, well, PDF into data, first we'll complete this. If you want to do a PDF, generally when you convert a PDF into data, I'll tell you when we are doing the natural language processing. Okay. So when we talk about is this kind of data analysis, we always go for CSV or JSON, but there are completely different ways of handling those things. So I have taken the example of a very most popular way of doing data analysis, that is using a CSV file. So now this is examples of data exploration. And these are some of the things which you can do: finding the number of rows and columns, summary statistics, first and last few rows, what are the names of the columns, what are the data types of the columns, whether it's a categorical data or whether it's numerical data. So if you remember last time I told you there are three main types of data sets: integer, float, and a string. And you will see that Python handles those data type automatically, but sometimes it gives you errors. And in those cases, how we will be making sure that our data type of the column is correct. Okay. Another thing, it's quite possible that whoever is doing data entry, they have duplicated the data. So although the file which we have downloaded, it doesn't have duplicated data, but I have duplicated it so that I can show you how you can get rid of duplicated data. Okay. And there are several other types of exploration methods. Then on data cleaning, one of the major issue is getting rid of how you will handle missing values or how you will handle duplicate data. So these are the two things which I will be showing you how to handle that, because you may wonder why I particularly chose this data set. And while I show you this data set, I will tell you why is it very interesting. Then data cleaning part is, again, as just I mentioned, that you may want to change the data type of columns, or you may want to change the name of columns, because sometimes they create problems. Another thing is, whenever you are working with data, first of all, you should formulate an objective of your data analysis, because it's quite possible that your data set has 100 columns and you may not need all 100 of them. So there is no point in reading the whole data. So you may want to, suppose you are doing house pricing, you may want to calculate the house price, and you have 100 parameters. It's quite possible you may not need. So you may find some of them irrelevant. And in those cases, what you can do, you can ignore unnecessary data. So it's totally up to you. And there are some other ways of data cleaning, and not every data set has to go through the same process that you should be aware of. So you may find problems in some data sets, you may find one kind of problems, in some data sets you may find another kind of problems. Okay. 4 and 5, analyze data. And I have given you, for example, it's the file which I have mentioned. It has 7 columns, New York City leading causes of deaths. Now, let me give you a background of this data set. It gives you the leading causes of deaths in from 2007 to 2014 in New York City. And they have 7 columns, and 7 of those columns are, they have given year, the gender of the person, and the cause of the death, leading cause of the death, and then number of deaths, and then the race, and then they have 3 numerical columns. One is to number of deaths, then age adjusted death rate, and then there is something called death rate. So we will be focusing more on the number of deaths, because that for the type of questions which I wanted to answer, you can feel free to just explore, or you can, if you want to extend your analysis. So the kind of questions which I've tried to answer is find the unique causes of deaths, because I was interested in knowing what are the top causes of deaths in New York City between 2007 and 14. And what are the, so basically I wanted to know the count, that how many people died from those particular diseases, and what are the name of those diseases which were leading causes of deaths. So I wanted what were the unique, what were the different causes of deaths, and you will see how we found it. Now, how many total number of people died every year by gender, and by leading causes, and by race. And then again, it's the total number of deaths every year. Okay, so will try to, so before I started doing my analysis, what I will do, I will, first of all, if I'm interested in that particular data set, I'll download that data set. Then I'll look at the metadata. I will do exploration. Okay. And then after exploration, I will try to formulate the questions. What exactly I'm looking in this data set? So before you start, so don't jump directly into analysis, because you may get some results which are not very important. So formulate the questions which you want to answer, or just make sure what exactly you want to see in this data. So this is a very important step, that you know beforehand. You may come back and change your hypothesis, or you may want to come back and change your questions. But it's always good that you start with 2 or 3 questions, main questions, which you want to answer by doing analysis on that particular data set. So I hope you are understanding the importance of having these questions beforehand. So you may want to extend it, you may want to modify it, but definitely you should have something to start. Don't jump on analysis before formulating your objective. And then we'll do visualization. Okay, so we'll do. So let's start programming. I have given instructions in this slide, and I will quickly take you through the steps. So there are 2 ways of using Jupyter. Since I'm not sure how many people are want to follow it online, and how many people are serious and they want to continue it. Because if you want to do some more data analysis and you want to continue it, I would suggest that you download Jupyter Notebook. And the best way to download it on your machine is download Anaconda distribution. This is a whole package, and it is by Anaconda, which is a company. And it packages Python and all kind of Jupyter Notebook and all kind of environment. It's a complete package which comes when you download this. So download steps, they are very simple to understand, but in case anybody has some problem or they want to know about specific steps, they can just contact me and I'll give them the resources where they can follow step by step how to download it. And those who just want to do it right now, they just want to get the feel of it, we can do it online. There is an online resource also. So I'll take you through that resource. So I will start sharing, and before that, let me give you the file. So let me, I am copying two files in this chat box, and I want you to download it from the chat box to your desktop. Okay. This is a CSV file. And then another file is the Jupyter notebook. Okay. And if you are doing it with me, okay. So I want you to save it on your chat box, on your desktop. And then let me take you to how you have to do it. Okay. So can you all see my screen? It's a Chrome. I'm assuming you can see. Okay. So I will do Jupyter. I will just do a Google search on Jupyter Online. Okay. I'm doing this Jupyter Online. And the first link you get is Project Jupyter. Try Jupyter Notebook. I'll click this. And then the first option is try Classic Notebook. I'm going to click this. Okay. So you will see that there is a binder, and it's going to take a few seconds. Let it load. Okay. So when you see this screen, I'm making my screen larger so that you can see what are the different options I'm talking about. So if you take a look at the top of the screen, so if you take a look at the top of the screen, there are several options. And one of these options is file. So let's click this option. So I'm going to click this option, file. And there is something called second tab is called open. I'm going to open this. Click open. And you will get a page like this. On the right hand side, I hope I'm not going too fast, because if you're done with it, then most of you will come. So if you take a look at the right hand side, on top, there is something called upload and new. Now, Jupyter notebooks have extension .ipynb. So the two files which I have pasted on chat box, and you have downloaded it on your desktop. So one of them has an extension ipynb. So what I'm going to do, I am on this Jupyter Notebook binder platform. And if you take a look at the right hand side, there is a one button called upload. I am going to click this, and this is called upload. And if you go to upload and go to desktop, and you will see your two files. So I'm going to select these two files, okay, by pressing Control, and I will say open. And if you take a look at the screen, both the screen files are available on this interface for uploading. I'm going to click upload for both of them. And if you can see, this is the CSV file is available here, and the notebook is available because IPYNB is a notebook which we will be using. It has all the programs written on it. Okay, so this becomes your, so both these files are now on Jupyter Binder. The problem with this is generally Jupyter save it automatically if you are using the Jupyter on your machines. I would say that don't forget to download this because, or if you are working because you already have it downloaded on your desktop. So you can, whenever you will use Binder, you can always upload it like this and start working on it. Okay. But if you are doing it new file, or if you are doing analysis on your own and you want to do on Binder, I would suggest that you, whatever work you do, when you are done with that work, download it on your machine. Otherwise, you are going to lose your file. Okay. So now we have these two files. I'm ready to start. Okay. So I'm going to click this file on the right-hand side, which has an extension .ipynb, and this is my Jupyter file. Okay. So I have this file, and one more thing which is very important. If you go back here, you will see, I'll show you the CSV file. What kind of files are CSV files? Let me click this. So as you can see, the first line in a CSV file gives you the name of the columns. And you can see every data point is separated by a comma. And that is why it is called a comma separated values file, CSV. Okay. So if you want to make a CSV file, you can always open a notepad, I think, and save it as CSV file. But luckily our file is already in the CSV format, so we don't have to do it. But since you are taking a class on data analysis, so these are the things which you should be knowing. Okay, so what is a CSV file and what exactly is the structure of a CSV file? So as you can see, all the data points are separated by a comma. So that is why they are very easy to, whenever who is doing data collection, it's very easy to maintain these files. Their size is very small. And the best part is you can open CSV files with Excel. So that is a good thing if you want to see it. So let's go back to our notebook and let me explain to you each and every component of this notebook. Okay. So the first option, file. If you click this, you will see several things. You can open a new notebook. You can make a copy of this notebook, save as. Now save as saves it in the binder folder, which you don't have access. So every time when you are opening it, you will be starting with a fresh binder. Then it becomes a problem. So if you want to rename it, you can rename it. But the most important is the option download as. And I would suggest if you are making a new file, you should always download it as. There are different ways. .py is if you want to open it as a Python notebook. So I would suggest download this notebook. Okay, download this notebook. So if you are using any other machine or if you decide to come back later, you will always have your notebook. Okay, so it's always a good practice. You download it, and when you open it the second time, again, you follow the same steps, open Binder, and then you can open this Jupyter notebook. Okay. So this is a very important step. Then let's see what exactly is Jupyter notebook. As you can see, this and there is a number. Where there is when you click this gray area, it gets highlighted, and this is called a cell. Okay, So, and every cell has some number outside it. And then let's go back to the top menu, which says edit option. And you can see that you can cut cells, you can copy cells. So what exactly are cells? Cells are this horizontal. You can say it's a space where you will be writing your code. And then you can delete cells and do all kinds of options are there. Then you do view. So if you want to toggle from header and then toolbars, you can use this. Okay, could these files be changed? Okay, I'll do that. And then, okay, now one very important thing is just to keep, just to do very simple kind of analysis, because your Jupyter notebook, the file, when I say Jupyter notebook, that means key notebook, this file, and the data file should be in the same folder. So I tell students that it's always, it's the easiest thing you can do it. So if I take a look at the binder, you can see my Jupyter notebook and my data file, both are in the same folder. Okay, so they are not in the different folders. Otherwise, you have to give path to the file and then it becomes complicated. So just for the ease, you can keep it at the same place. Then you can insert cell above, cell below. Suppose you decide to add in between, you decide to enter something. So you can always insert cells above and below. And then there are several other options. Run cell. You can run this program cell by cell. So there are several options. Now this is kernel. Sometimes what happens, the way Jupyter Notebook works, it's called kernel. And sometimes it happens that it just freezes, or it stops giving you correct answers, or it starts taking too much time. Then you will use kernel functions. So to stop the processing of your program, just do and say interrupt kernel. Okay. So the top option is very important. And sometimes your cells would not give you correct answers, or what they just don't give you output. In any of those cases, I generally suggest students to select the second option, and that is to restart their kernel. So there are several options: restart and clear output. That means whatever output you have obtained, it's going to clear it so that you can run it again cell by cell. And then restart and run all will do what it will restart the kernel, and then it will run all the cells. Okay. So these are some of the options which you can play around with this file afterwards. And then if you just want to close everything, just do the shutdown kernel. Okay. And then so that your kernel stops running. So sometimes at the back end, it just keeps on running. So this is the options which you have. Then you can see the second line, which is a toolbar, save, and then add a cell, insert cell below, cut a cell. The options which we have there, these are the shortcuts for those options. And then copies, paste cells below, go to ups. You can move the cells up and down. And this is a very important option because we will be using this option, and that is to run. So when you write your code in a cell and then you click run, it runs that cell. Okay. So this we will be using a lot. So yeah, this button, just know where exactly is this button, because otherwise the program, we just want to make sure we write code for one program and then do it. So let's start with our step one in analysis is reading your data. And the data, for that we have to first import pandas library. And pandas is the name of library. Whenever we want to use any library, we have to import it. Import is called just once in your program, and it's always done at the beginning of the program, because we will be from the second cell or the first Even in the first step, we have to use pandas, all the functions that are in pandas library. So that is why we have to call it just at the starting of the program. And then PD is the alias. So basically, instead of writing pandas everywhere, we have given it a short name. It's PD, and it's a universally accepted alias for pandas. So if you look at other notebooks, or if you look at other Python programs for data analysis, you will see the same thing. And then I needed some other library, which was NumPy, and NumPy has the math functions. So I'm going to give it an alias NP. And so these are the two files which I want in my program to do all these, do all the data analysis. Okay, so the first thing, so the function that is used for reading a CSV file, it is called read underscore CSV. So first I am going to call the name of the library, and then I will write the function which I want to call. Okay. So this is the first thing which you have to do, because I'm calling this, I have a CSV file. That's why I am calling this read underscore CSV function. And then in the parentheses, I'm going to write the name of the file. Since it's a string, so I'm going to give it in, the name of the file should be given in double quotes. Now, this is the syntax of read underscore CSV. If you try to change it, or if you do any error in this, it's going to give you, it's not going to work, and it's going to throw a warning to you, or and it's errors. When people start doing programming, the most common type of error is syntax error. Syntax error is basically if you are using the wrong form of the language, that gives syntax errors. So make sure syntax error are very easy to resolve, because you can readily see that, okay, I might have used some wrong way of calling a function, or I might have used the function name as wrong. Okay, so these are the things which you have to be very careful about. So that will, so I'm going to, I wrote this. Now I have given you some other options. So as I told you earlier that we will be interested in only the number of deaths. Okay. So I'm not interested in the last two columns, which is death rate and age adjusted death rate. So I may want to uh, just ignore those columns, and I may want to just upload or read only that first five columns. Okay. So that is why I can use this also. But since we have a small data set, I thought I can read the whole data set. But you have options. So you will find a lot of these small notes in this notebook, just to give you a variation of what other things can be done with this in this particular situation. Okay, so just if you want now, okay, so if you want, you can always uh, work with those options also. Now you can see there is something called hash is written. So in the last class, I told you that whatever is written after hash, Python or pound sign, Python just thinks the rest of the whatever is written after hash or pound sign is your comments. So it just ignores those. And you will find in this particular program, I have written comments with each cell so that the reader knows what exactly is being done in that particular cell. So it's easier for you to understand this particular code. Okay, so it's always a good practice to have ample comments in your question, in your program, so that if somebody else is reading your code, or even if you are reading your code after a long time, you will be able to know that, okay, what exactly is being done. So we read the data set. Okay, now let's do the step 2, and that is start exploring our data set. So we, okay, now this is another important thing is we read the data set and we saved it in a data frame. So what pandas does, it saves the CSV file in a data frame, and I have named that data frame as DF. Now, in the last class, we discussed about how to name a variable. There are some uh, uh, rules for naming your variables, but here it's not a variable, but the same rules applies to when you are naming a data frame. Okay. So your data frame cannot have two words. Data, you cannot leave a space between the names of your data frame. So you will see that I have done either 1, 2, 3, or make underscore and do name your data. Okay. So this is one of the things which you should remember. Okay. So now let's explore. Now, what kind of exploration are we doing? The first thing is I want to know about my data set, and this is called the summary statistics. Summary statistics is basically mean, median. Those who are familiar with these terms, mean is just the average. So it gives you a brief overview about year. Now, when you call this function dot describe, now I am going to, so now I don't have to call up pandas, because because now what's happening, so now I did this, I'm going to run this. When I wrote this, I'm going to run this. Okay. Now there is a star coming. That means my program is running. Okay. Now on the top, there is something called connecting to kernel. So basically when it stops running, you will see the star will go. Okay. So let's go to the second step, because I have already done this program. So we can proceed. Otherwise, because so online, it's taking time. Now, dot describes give you the summary statistics of your data. You will see that only numerical columns. Now, you can find mean of only numerical columns. You cannot get the mean of a gender column. Okay, so that is why this Python has, or you can say the pandas has given me summary statistics of only year. Now, year, although year is not a numerical data because it's a categorical data, but since Python saw the numbers 2010, 2010, so it's given you this summary statistics. So for in this particular type of data set, this is irrelevant. But you can always, when you do it, so dot describe is a good thing to do first. So all the numerical columns will give you the summary statistics. In this case, it's not very relevant, but you should know that. Now, the next is find the number of rows. So this data set has, so first index shows you the number of rows, which is 1096. And the second is shows you the number of columns, which is 7. So basically my data set has 1096 rows. It was easier for me to just let me open this again. I'll keep it open because it's not, has lost contact with the, okay. So I'll keep on using the same file. So dot shape gives you the number of rows and columns. So again, you write your code in this cell and then you run it. So if you run it, since it's not connected, it's not giving me answers. Let me show it to you in another. Just give me a second. I'm going to run it for you. So can you see this file one more time. Okay, now we were doing the shape. I'm going to run it. Now, since we defined df in the first cell, so I have to run it from the first cell. Okay, now it's 10967. You get that. Now, another thing is I want to know what kind of data set I have. So since it was a small data set, I opened the file. Suppose I have around 1 million rows in my data set. So I will not be able to open the file because it's going to take ages for opening it. So then this comes into handy, and that is the dot head function. So dot head function, if you just do dot head, you will see that if I run this df dot head, so df is my name of my data frame. So now all the information about this particular CSV file is stored in my data frame, which is named df. Now I have to call all the functions on df. So dot head is a function which is used to see the top 5 rows. So if I just do df dot head and I run it, I'm going to see just 5 topmost rows. But I want to see the 10 rows. So I'm going to, in the parentheses, I'm going to mention 10 and I'm going to run it. Now you can see I have 10 rows. And if I look at these 10 rows, I can see a lot of missing values. So in the row, sixth row, I can see the last 3 columns don't have any values. So that means I have to deal with the problem of missing data. Now the problem with this, why is this node Excel file interesting? The Excel file is interesting. Generally, when we have a missing data, the column, that particular placeholder, that column has empty space. Or we write NA, which is not available, or we say NaN, not a number. But in this unique data set, it was interesting that instead of writing or leaving it blank, so either it is a blank or NA or NaN, instead of writing this, they have put a period sign. And as you know, that period is one of the special characters and it's a part of a string data type. And that is going to create a lot of problem. I'll show you afterwards. So as you can see, this is a column of deaths in which we will be interested because we are doing data analysis on that. And then what happens is there is a dot. So now Python gets confused because this column becomes a mix of numerical and string data. So you will see how we are going to handle this situation. So the first top 10 rows, and we found the problem in our data set, which is this uniqueness of having a period in place of empty data. Then there is a function called dot tail. It will give you the last 10 rows, last 5 rows. And again, 10, if you leave the parentheses blank, it displays the 5 rows. And if you put some number, it's going to, inside the parentheses, it's going to give you those many rows. So as you can see, the last 12 rows are there. And again, I can see a lot of empty spaces with dots. So that means that is a problem in my data set. Now let's find the column names because we will be doing data analysis on names of the columns. So we want to know the exact name of the columns, because if we don't know the exact name of the columns, then it's and we may want to we may do some errors in writing the name of the column name and changing the case or something, or not leaving the space. In all those cases, we should be knowing what is the correct name of your so if you do df dot columns, it's going to give you the name of the, so I'm going to run it, and you can see that I have the name of the columns. Okay, all the 7 columns, because I uploaded the whole data set. Now I am showing here you to change how you can change the name of the data column name. So there can be many reasons for changing the name of the column, and one of them is I wanted to change the name of the column from sex to gender. Okay, so this is the syntax which you will be using. The function which you will use to rename the column is dot rename, and then you are going to give the name of the columns, and you will put a colon, and then you will replace it with gender. Okay, so this is the correct way of renaming the column. It's quite possible in the second line I have written, if you want to rename multiple columns, then in the first you will use the same function, but instead of just giving the one name of the columns, you will give all the names of where you want to change the name, and then you are going to give the name of the new name of those columns. Okay, so you can change either one, you can rename one column, or you may want to rename a bunch of columns. This is the way you can do it. Okay, so now I am going to run it, and as you can see, I renamed. So in the first step, I renamed the column. In the next step, I want to know what are the new names of the column. And if I run this cell, you will see that now the column name sex is replaced by gender. Okay, so this is how we can rename our columns. And this is a part of, you can say it's data cleaning part, but we have done it in data exploration. I want to know the number of rows just to see if any of the row, the last of the entries are missing. So this is a way I can count the number of rows. Dot count is the function which is used. So if you see, if you are following this analysis, you can see we are using very simple words, all the English words. And just by taking a look at the name of the functions, you can see that, okay, what exactly it may be doing. Okay, and then and another thing is, the first part of your code is the name of the data frame, and then you put a dot, and then you call the function. Okay, so this is your function, and this is the name of the data frame. So this is how you can use different functions on different on a same data frame. So we are still exploring. This is very important. One thing I would like to mention, the column indexes. There are two ways to access any column. So let me annotate. So this is a data frame view you have, and you have some columns. So let's say we have 4 columns, and then there are 3 rows in this data frame. So this will be, there are 2 ways to access any column. Either you can access the columns by name, okay, or you can access the columns by index. Now, what exactly is index? Index means, so there is a index given to, there is a number given to each column, starting from for each row and each column. So this is your row 0, 1, 2. So remember, the column indexing starts from 0. So if I have 1094 rows in my data set, you will see the first index, and you can see in the file, the first index will start from 0. So it will go from 0 to 1093. So don't get confused because indexing starts from 0, not 1. Similarly, your column indexing starts from 0. Okay. So this is, you have to be very careful because if I want to access 23 is written in my first row and first column. So if I want to access 23, I will say column 0 and row 0. So in data frame DF, the index of, if I want to access 23, so it is in the 0th column and 0th row. So the to access 23, the two indexes will be 0 and 0. So this is how it is done. Okay, so I hope it's clear. You can see this is starting from 0. Now we have column names, but the index of year will be 0. Okay, so this, be very careful. Now, if I want to access these columns by index, I have to use a function ilock, and then I will make a square bracket. And then first index will give me the column, row number. And the second index will give me the column number. Now, I have 7 columns, but the index of this column, last column, will be 6. So if I write 7 here, I'm going to get an error. So I have to make sure when I do, when I'm accessing any column or row, I have to be very careful that if I want to access the last row, I have to use ilock. If I put a colon, that means I want all the rows of the last column, because last column will have index 6. So I have given you several ways. When you print all rows and all columns, you are going to use colon and colon. So colon at both rows and column places means all rows and all columns. Okay. So in the interest of time, I should, I think because I have given different variants of this, how you can access by index. So I am leaving it to you all. You can go through it. In case you are unable to understand, you can ask me, because the result, as well as, now make sure you are running all the cells. If you don't run anything, then definitely that information will be lost and Python will not be able to process that. Now, if you are accessing columns by column name, then you have to use .lock function. So don't get worried about that. Okay, oh, you are unable to follow up with so many functions. Don't worry. You go over this uh, notebook 2 or 3 times, and if you run it on your own, then you will be able to understand it very well. So .lock is the function, and the usage is similar, but now we can give a file name, sorry, column name. There is another way of accessing columns, is just by giving with the data frame dot the column name, and you can access the columns, just the column, not the rows. But the problem, it gives you a problem when there are spaces between your column name. Then it's not, this function is not going to work. So although it's a very easy way to access the columns, but then the problem is if you have a column name which has a space between its name, okay, then it's going to give you error. So if I run this cell, you see that it's going to say invalid syntax. Then data cleaning. Okay, so data cleaning, I have taken, I will show you two basically main things, and that is how to handle duplicate rows. And you will see there is a function which first, so you had this function finds if there are duplicate rows. So I said in the first line, I asked it to df.duplicated gives you if there are any duplicate rows. And I have said that, okay, if there are any duplicate rows, save here in dup rows df. and then print it. So luckily in this data set, I have 2 duplicate rows. Okay, these two, and it printed these two, the rows which are duplicated. So this handles the situation when it is duplicated. Now, when I have a duplicate row, I want to get rid of those duplicated rows. And for that, what I am doing is I'm dropping all duplicate rows. So suppose this is row 5, and then this is duplicate row 5, and this is again duplicate row 5. So what I will do, I will delete these duplicate rows, but I will keep this because this was the original row. And that is what it is doing. Drop underscore duplicates, drop all duplicate values except the first value. Okay, so it leaves the first occurrence, and rest of the duplicate values it just deletes. So I have cleaned my data and I got rid of all the duplicate rows. So this is what I have done. So this was one of the problems which I wanted you to know. So you just, and if there are no duplicate rows, then you don't have to delete anything. Okay. Now, next thing is, if you recall at the beginning of the when we were exploring our data, we saw some very interesting things, missing values. So let's handle that. And this is the cause of concern, because I am interested in analyzing deaths. And if you see the data types, the deaths column, the data type of deaths column is object. Now I cannot do any math on object data type. I need numerical data type for to do any kind of math. So this is a problem because object means it's a mixed kind of data type. It's not a straightforward numerical, because as you can see here, it is considering it as an integer, although it is a categorical, but we are not worried about it because we are not doing any analysis on um, the year part. So we don't have to do any math on this. So we are fine. But this is a problem. The rest of them is also a cause of concern. But since I'm not analyzing it, so I am not worried about this. But this is a cause of concern for me, that deaths is object data type. So I will not be able to do anything. And I will show you how you will not be able to do anything. So I want to know how many people died from 2007 to 2014. And for that, I'm going to take this column. How am I going to take this column? I'm going to do the column data frame name, and then I'll do a bracket, and then I will write the name of the column which I want to do a math. And then I will do dot, and then I say sum the whole column. This is what I wanted, because I wanted to add the total number of deaths and get the final count. But I am getting a garbage. Why am I getting a garbage? Because the data type of this column is not a numerical data type. Okay, so that is why it's a cause of concern. That means I have to do data cleaning, and I have to change the data type of this deaths column from object data type to a numerical data type. So that is what I'm going to do. Okay, so this is the reason behind changing the data type. So this is a two-step process. Now, don't think this is the only way you can change the data type. There are other ways of changing the data type. It totally depends on the problem. This was I have other ways. I know other ways also, but for this particular situation, we are just doing it using the replace. So first I'm going to replace the dots with NaN using the numpy function NP. So this is my step one. So I changed all the dots or period from to NaN. So I converted all the dots to NaN. Basically, I replaced it. And then it was easy for me because Python knows how to handle and NumPy knows how to handle those data sets with NaN, but not with dots or exclamation or whatever object data type. So now I changed it and I again saved the resultant data set into DF1 because now I want to get rid of the earlier DF1, the old DF1, and I want to replace it with a new DF1 where my all the dots are replaced by NaN. And the next step, I am converting that column with NaN to numeric, and I am using this function to numeric. There are other ways of handling this also. So, but at least you now know the one way of doing it. Okay. So now I'm fine because now my data type is converted into, so I'm going to run this. I have to run all. So again, whenever you make any changes in a cell, make sure you okay. So I'm okay, I have to run again. Okay, now how many total number of people died? It's 400, it's close to 425,000 people. Okay, so this now, since my deaths data type converted, the column data type converted into numeric data type. So now I'm getting the result. So now, earlier you see it, I was getting a garbage number. Now I can see it's 400. So this is the data cleaning part, handling a unique situation. Now let's do the data analysis. And the first question which I'm going to find is, the answer is, what are the different unique causes of deaths? So now you are a little familiar about how to use different kind of functions. Nobody in this world knows all the Python functions. So you don't worry. You don't even have to just the more you use, the more familiar you will get to the different kind of functions. You should be familiar with basic functions, but definitely depending on what kind of question you are trying to answer, you can always find what are the different functions. So you can see, I wanted to get the unique causes of deaths. So I found this column, I accessed this column by column name. And then I said, what are the different unique values? And then I want to print, I want to save that unique values in another data frame, which is cause death. I've given it a name, and then I'm printing it. And as you can see, I got 26 unique causes of deaths. Okay, so I got unique. When I said unique, it gave me 26 count. So the data set has 26 unique causes of deaths, and you can see the names are there. Total number of deaths by year. I want to group, find out that how many people died every year. And for this is a very good data analysis function, which is called group by. You should look at the syntax, how it is used. So I want to group by then a total number of deaths by year. As you can see, I have data like this, 200, 2010, 2011. It can be cause 1, it can be cause 2, it can be cause 1, it can be cause 3. Okay. Now for 2010, I wanted to add these 3 number of these three numbers. I want to get the sum of it because I want to group my data by year as well as total count. And as you can see, I got these counts. So from the table, I can see most of them are the number of deaths every year is almost equal. There's a very little difference between the total number of deaths. And then I did the group by gender. So more females died than males in the 8 years. Dot sum is basically gives you the name, the sum of the column. So when you say dot sum and you give a column to it, it's going to sum the whole column. If you say dot sum with a row, then it's going to sum the whole row. Okay. So dot sum basically gives you whatever rows or columns you are using. So let me give, because we have a student presentation. So I quickly want to wrap this. Now I have used the same group by function, and I'm going to group it by race and ethnicity. So as you can see, the maximum number of deaths happened for white non-Hispanic. Okay, and it's close to 206,000 and so on. Now this is way of making a bar chart. Bar chart is where you have a category and the count of that category. That is represented by bar chart. So what did I do? The easiest thing is I saved the values, which was returned by group by function in another data frame, which is total deaths by race. And then so here you can see I'm making a plot in this line. This you have already understood. So I'm doing a lot of things. I have combined several functions. So till here, I added all the values. And then I said, okay, now write those values in descending order. Okay, so I have used two function, and this is a very good functionality or property of Python, because, or you can say it's in pandas, because you can combine many functions in one line just to get the final result. So this is a very good option which is given with Python. So as you can see, not only you found the sum of this, not only you found the total deaths by race, you can also sort them. And that is what we have done in this part using the function sort values. Okay. So, so this is the best part about this Python. And then in this line, I'm making a bar graph. So as you can see, this table is not helping me too much. If I look at this table, this is not helping me too much. But when I make a graph, see, you can right away, just by taking a look at the graph, anybody can say, okay, the maximum, in the 8 years, white non-Hispanic death count was highest. And there are some people who have not mentioned their ethnicity, their count is very low. And how you are going to make it? You have going to make this graph by using this function dot plot dot bar. And then you have given the name of the data frame. That is the best part about pandas, that you can make a graph right away from the pandas data frame and just give it dot plot dot bar, and you will get your plots, bar plots. And you can get different other kind of plots, but in our situation, the best way to represent the results is by making a bar plot. So there are different kind of bar plots I have made. Now by leading cause, we found out that diseases of the heart was the leading cause of deaths, and it caused more than 140,000 deaths. Okay, now we are not worried about charts. Sorry, we are not worried about tables. So instead of writing my result in a table, I made a chart. Again, I used the same functions, which is dot plot dot bar. And then I am going to do it by gender. So in 2007, 27,000, close to 28,000 females died and close to 26,000 males died. So basically now I have grouped it not only by year. I have my grouping criterias were two, by year and then by gender. And then I said, find the total number of deaths and add them. So if you try to do it manually, it's a very cumbersome process. But as you can see, the beauty of the programming language is in just one line, you got this result in few seconds, which would have taken a lot of time and efforts, if even if it's such a small data set, if you try to do it manually. Okay, so I'm going to quickly wrap this because we are almost done. And this is another way of drawing a bar chart where you can see the gender wise every year, the gender wise distribution, and you can see it's almost men and women count, death count is almost similar in all the years. Okay, and this is another way of showing the same thing by grouped bar chart, because now you can do the comparison also. And there is the way to do it is similar. So that completes the data analysis part. If in the next class, if people are interested, I can show you how to make the report on these charts, and we can do it from here. If you have any questions. Okay, now how can you specify what type of bar chart? For that, you have to know about different charts. That which is another discussion, which is I have taken a course on data visualization. So you have to read the basics. Okay, so in case you have a question, I can you can ask me, you can email me about this. I can direct you to relevant resources, but then you have to know the basics of how the different charts are decided. Okay, so that is all for today. We have I have given some couple of, you can just, it's for you to just read through it. Something which may be useful for you, but not very relevant for the data analysis part. So I have, that's all for today, but don't log out because we have a student presentation. And Saina, we have a student, high school student from joining from South Carolina. And she is, she will be presenting to you. So Saina, can you unmute yourself? Hi, can you unmute yourself?
Hello.
Yeah, so Saina will be sharing her screen, and she has done a project on COVID, and it's a data analysis project. So Saina, you can start.
Hi there. My name is Simon Shrivastava, and I am sharing my screen in a minute.
I think I have to stop share. Can you share it?
I'm trying.
You can share it now.
Yes. So I did a data analysis on COVID-19 in South Carolina. So the objective of this analysis was to see individual counties in a state and the cases as well as deaths in that specific state. So my data source for this project was from the New York Times GitHub. It is a public GitHub that is constantly getting new information daily. about the COVID-19 cases. I did this project in August, so I only have data until August, but it has been updated ever since, and below is the link. So this is the overview of the data that I was working with. Here you can see that there were 6 columns, and there were 398,852 rows and there were 6 columns, but I actually got rid of this column because it did not contribute to my data, to my analysis. So the original data had data from all states, that being and it was from the beginning of when the first case came out in January. I live in South Carolina, so the state I selected to research into was South Carolina. The first recorded COVID case in South Carolina was in March. So this is my data analysis. This is a bar graph which has the total number of cases in South Carolina by county. And this is important. And as you can see, Greenville is very high, and while McCormick is very low. This gives a more in-depth view of the previous graph, except this is in a line graph. There are 63 counties in South Carolina. So these are 63 individual maps that show the growth and the death of every single county, and they are quite similar, as you can see. This is a line graph, as opposed to the bar graph that we saw before, of the total numbers of cases in South Carolina per county. This cyan line that you see is Greenville, and this green one is I think Richland. So here are a few takeaways from this entire analysis. Counties like Greenville, Charleston, and Richland had the most cases as well as the most deaths. COVID cases after June skyrocketed, which explains because school was out and there were more people. People had more time on their hands, so they wanted to go out, and summer had started. And in July, when in South Carolina there was a mask mandate, there was a slight decrease in cases, but not a significant one. I just want to show my actual coding behind this. I obviously used Jupyter Notebook that you guys just went over. So here are all of the packages that I used. And then this is me first putting my data in the actual program and computing it. Then here I am sort of analyzing or getting an overview of what my data actually is. Data.shape is actually telling me what the rows and columns are, the number of rows and columns. This is how I'm indexing my data. So that way I could, right here, that way I can only select South Carolinian counties, so I could only focus on South Carolina as opposed to national. And then I was finding out the shape of this data set. And then I realized, and this is, I grouped by county and cases. And this is how I got my graph. And then this is a more manual approach to creating subplots, which if you're making like a lot of subplots can be extremely tedious. This is a more computational and a more work smarter, not harder approach. Um, so this is how I made my subplots. Then using group by dot plot, and we use this to kind of determine how big, how tall, and how wide our program is, how our plot is going to be. And this is essentially adding like a legend to it, a key. So here what you see is actually where the exact location of every single one of these. So that is how I got them. The modules that I used in this project, modules or packages, both are the same thing, is pandas, which is very important. It is one of the most basic yet most utilized modules out there, especially in Python and in Jupyter Notebook. Matplotlib, it is well known for being used to make plots. NumPy is used for mathematical calculations, and datetime is used when there is a date value or a time value in which you would need to, maybe if you're trying to find days, or in order to make a time series. And thank you for your time, and thank you for this opportunity.
Thank you, Saina. So that's all for today. And I hope that you enjoyed this class and learned a lot from it. So let me know if you have any questions. I can always guide you to the resources. And yeah, so I hope all of you got the recording for the last class, and it's on a YouTube. So I'll try to make the recording available as soon as I can for this also. But feel free to reach out to me for your questions with your questions. Thank you so much. See you next week.